Yes, sir.
states. Okay. So today I'm going to speak on the environmental aspect, environmental pollution and its management. What are the current problems with respect to environmental pollution? Nowadays you are experiencing the impact of environmental pollution, isn't it? What are the experience impacts you are experiencing today? The impact of climate change. What are the indications of the nature? Nature gives the indication of various changes in the environment. What are the changes, indications the
High,
nature is giving?
high
Global warming.
temperature. Sir.
Yes,
High
Global
temperature.
warming.
high temperature last summer
Global warming.
experienced.
Global warming.
So that is like there are so many. The nature gives the signals about the environment changes.
Sir, natural disasters.
Yes, the recent disaster, in which is a earthquake. Recent earthquake is from last week. We experienced natural disasters. Like that, there are so many signals the nature is giving today, but we are not taken it seriously, even though it is giving a lot of signals, but we are not taken anything seriously about to overcome these problems. So like that, there are so many environmental aspects, problems arise new. You know already what are the environmental pollution. This is a common word, everybody knows environmental pollution everywhere. But what are the recent addition to these pollutions? Can you tell me any changes with respect to solid waste pollution, plastic pollution? Plastic pollution is one of the most important environmental pollution. So in that, microplastic, what is microplastic? You may come across the term microplastic nowadays, which is the most important environmental pollutant, which we can detect in various samples, even including the blood samples, in water bodies, soil, everywhere you can see the microplastic. Now, what is the impact of microplastic on the human health? So all those things we are going to explain, all those things. So just I'll go through the important pollutants which we are dumping to the environment and their impact and their control measures also. What are the current measures, technologies available to control these pollutants? Okay. I'll show some of the PowerPoint pictures. 1 minute. Okay. Open it up. Full screen. Go to the next slide. So in the beginning, I'll give you some of the important aspects of environmental pollution. Later, I'll concentrate on the control aspects, management of environmental pollution. The pollution is the introduction of harmful substance or products into the environment. It pollutes water, air, and land, everything. So you know already all these things. So some of the pictures I want to show you that the extent how we are polluting the environment. The solid waste, the plastic, garbage, everything we are dumping ultimately reaches the water body and carried into the oceans. You can see the water pollution is one of the most important pollution where can see the two types of water pollution. One is a point source and another one is a non-point source. Point source are the easiest to identify and control. We can find out where it is coming, the pollutant, whereas the non-point source are ambiguously defined in order to control it. And also some of the point source example for point source of pollution include waste from products from factories, sewage system, power plants, underground coal mines, waste from oil wells, or the examples of point source of pollution. So non-point source encompasses a large range of sources such as when a rain or snow moves through the ground, pick up pollutants and towards a major water body. So it along with the water, it carries all the pollutants which for example, agricultural runoff, which carries the fertilizers from the farms, which contains a lot of nutrients, which encourages the growth of the algae and all those things. That is a agricultural runoff, and air pollutants getting washed or deposited on the earth, stormwater drainage, lawns. So these are the example for non-point source of pollutions. This non-point source of pollutants, we cannot control it because it has a wide encompasses a large range of sources. So example for non-point source, so it is the water is carried from the land on this, along with all the pollutants. So some of the picture to show the air pollutants, where how we are polluting the air, you can see that. And also the one of the main cause of air pollution is the release of carbon dioxide. Already you know all these things. And sulfur dioxide as another air pollutant, which is released into the atmosphere by the burning of sulfur containing compounds such as fossil fuels. So like that, you can see that the chlorofluorocarbons, these are all the. Pardon? Hello? Pardon? Hello? Can you hear me? Hello?
No, sir, continue the
Hearing you,
class.
sir. Maybe some disturbance from other persons. Please, you continue,
Please
sir.
continue, sir. Please continue, sir.
Continue, sir. Class continue.
So these are major causes of air pollution includes the chlorofluorocarbons, naturally also smoke from fire, methane released from the livestock, volcanic eruptions. So these are all the source of air pollution. And also, you know, the consequences of air pollution, which leads ultimately into atmosphere and likely in the global warming, which is one of the important phenomena and which is widely talked and one of the most burning problem of the current world today is the global warming. So I'm not going to concentrate much on that now. So land pollution, I want to show you the extent how we are polluting the land. You can see that. So mainly land pollution in pollutants includes construction waste, C&D construction waste, agriculture waste, domestic waste, and industrial waste. And also you can see the construction wastes are dumped. And also agriculture is one of the most important source of pollutant now. So for all the agricultural activities, we depend on various types of chemical compounds and fertilizers to increase the productivity. So ultimately, and then the consequences of this we are facing today. For example, herbicides we are now using. Herbicides are used. Weedicides and herbicides are used. The farmers enormously use these herbicides and pesticides in order to control the weed because of the lack of problem with the labor problem. They cannot remove it physically, so they are going for the chemical method of removing the weeds. So they are dumping millions of tons of herbicides and weedicides to the land, which kills the harmful microorganisms present in the soil and reduces the soil fertility. Domestic waste, you can see that. Just I want to give the glimpse of that waste. And industrial waste are also dumped. The consequences of land pollution, air pollution, all these things you already know. I will not go much on that. So, and to show you some of the important pollutants, totally from all the pollutants, we naturally occurring chemicals, compounds in the environment that are presently in high unnatural high concentration, they are called as pollutants, including xenobiotics, that is synthesized synthetic compounds, chemically synthesized compound that have never occurred in the nature. We are produced, so they are also causing a lot of environmental pollution. Example, pesticides, herbicides are all the xenobiotic compounds. So what are the major hazards of pollution? Misplaced chemicals that cause harmful effects in the environment. That is also another pollutant definition for the pollutant, hazardous pollutants. Okay, so there are some of the compounds are considered as hazardous because of they are known to cause severe damage to the environment as well as the human health, like the toxic compounds, carcinogenic compounds. Some of the compounds are carcinogenic in nature. Carcinogenic means cancer causing, they can cause the cancer, and mutagenic, they can cause the mutation in the cells, chromosomes, genes, and teratogenic causes birth in the defects, flammable when they catch the fire, when they exposed to the air, and corrosive. So corrosive means they causes the corrosion on the metal, explosive, endocrine disruptor. So these are all some of the important harmful compounds. They are called as hazardous pollutants. So example, hydrocarbons, oil spills. So I just want to give some of the names of the chemical pollutants. And also heavy metals, they causes very severe problem to the environment, like mercury, lead, cadmium, chromium, zinc. So these are all the important pollutants which are causing various health hazards to the human beings as well as the animals. So this is the just a list of common environmental pollutants, source and all those things. Okay, so just given about the pollution which you are already known. It is not the new thing which I added. So only thing is just to give the brief about the pollution. Now I will concentrate on the methods of remediation. What is remediation? Remediation is any solution for the problem. So here, for the environmental pollution, what remediation we can do in order to control the pollution or to prevent the pollution which we are facing today. So now let us know about the conventional methods of remediation. Conventional means already which are known methods of conventional methods, which includes dig up and remove it to landfill. Any pollutants we produced that we are going to take up and buried in the landfill. And also cap and contain, that is capped and contained and maintained in the same land but isolated it. So these are the conventional methods. So what are the problems of these methods? Risk of excavation, handling and transportation of hazardous material, very expensive to find another land to find. So nowadays in the cities, you can see that the landfills are growing like hills, occupying large land, which is not sufficient to for this solid waste are produced in the cities, and also very expensive to find another land. The land problem is also one of the important thing in order to dig up and remove it in the landfill. So another problem is maintenance. Maintaining the same only is an interim solution. It is not the permanent solution. Keeping the pollutants in some other place or an isolated place is not the permanent solution for this problem. So it requires monitoring and maintenance of isolation of these pollutants in the land. So these are some of the conventional methods. They have so many drawbacks and disadvantages to the environment. So what we have to do is products are not converted into the harmless products but stay. So in these conventional methods, any pollutants which are produced or the waste which is produced in the environment, they are not converted into harmless products, but they remain in the same form that they are stay as a threat, also threat to the environment. So what is there any better approaches to overcome this problem, overcome these conventional methods of polluting, conventional methods of controlling the environmental pollutions, or is there any better approach? Let us see. What are the better approaches? What we can do? What we can do to overcome those problems of conventional method is destroy them completely if possible. That means we have to destroy the pollutants completely if possible. Or if it is not possible to completely destroy these pollutants, which we can transform them into the harmless substance. So that means from harmful compound to harmless substance. So that is the better approach is now, which we are looking forward to thinking. So it is, if it is possible, we have to destroy that pollutants. If it is not possible, then we have to transform these pollutants, harmful as hazardous pollutant, into harmless substance. How? So let us see what are the methods available nowadays. Methods already in use. Destroy. I told you in the destroy them completely. How to destroy? That is, high temperature incinerations are used to destroy the pollutants, particularly the hazardous substances. For example, hospital waste, biomedical waste are completely destroyed using high temperature burning of high temperature. That is, the method is called as incineration. And also that is the physical method of destroying the pollutants. And the chemical methods includes decomposition, like dechlorination, UV oxidations. So like that, there are so many chemical methods are used in order to completely destroy them or remove them. But are they effective? To what extent these methods are effective? Can it be very safe? Is it safe or not? That also we have to look. Burning of waste or destroying the waste using high temperature or chemical compounds. What is the problem? Is it safe method or not? We have to think. But they are effective. Completely we can remove and burn it and can destroy. But they have their own problems again. So, but they are very effectively can control that. But they can cause us another problem to the environment. Okay, is in order to overcome this, but only to, yes, it is useful to some extent. It can be applied to some extent. It can be used, but they have their own drawbacks. What are the drawbacks? Technological complexity. So we have to find out the suitable technology in order to destroy the pollutants or remove make them harmless. Okay, and then cost for small scale application. It cannot be used for small scale application is very expensive, and lack of public acceptance also, particularly burning of waste, burning of pollutants, burning of hazardous materials is not acceptable by the public, because especially the incineration generates more toxic compounds. When we burn some compounds, it are converted into some other compound which is more toxic than the original compound. And also materials released from imperfect incineration. So if it is not perfectly burned, imperfect or incomplete combustion of the pollutants also causes various environmental problems. Undesirable imbalance in the atmosphere. Example, ozone, again, it damages the ozone. Fall back on the earth, on the pollutant, when you burn the pollutants, the smoke or dust which is enter into the atmosphere, again will come back to the earth also. For example, dioxin production due to the burning of plastics leads cancer. So one of them everywhere you can see in the rural, particularly in rural area, all people they are producing the plastic waste. Ultimately, there is no proper disposal or collection methods available in the rural community, rural villages. What they do is they burn the plastic enormously. So that causes again the leads to the environmental pollution, particularly the dioxin produced when we burn the plastic is called dioxin, which is a very well-known carcinogenic cancer-causing compound. Okay, let us see what are the other possible ways to overcome all these problems. So what I had explained so far are the chemical methods, physical methods, conventional methods. These are all used. They have their own drawbacks, as well as, even though they are effective, they effectively control the pollutants, but again they will cause some other environmental problems. So by here, the another method which we can now are using are the bioremediation. So what we are explained as the remediation using chemical or physical methods. So that are effective, but they have their own drawbacks. So to overcome these problems, the more effective remediation now available is bioremediation. Bioremediation means use of biological agents or material to control all these pollutants. Effective approach possible. So it is also possible, either by destroying or rendering them harmless using natural biological activity. So biological material means includes plants, animals, including microorganisms, and their activity are used to control this pollution or pollutants in order to convert, to destroy or render them harmless using the same what we do in the physical chemical methods. But here, instead of chemical and physical agents, we are going to use the biological agents. Biological agents includes microorganisms, plants, animals, etc. So their biological activity is used to control this pollution. Okay, let's see. That is the main topic which I am going to concentrate is the bioremediation. So you should know what is the definition of bioremediation. The definition is use of living organism to transform, destroy, or immobilize contaminants in the environment. That is the definition of this bioremediation. So the ultimate goal of this bioremediation is to detoxification of the parent compounds and conversion to products that are no longer hazardous to human health and the environment. That is the ultimate goal of, the definition as well as the goal of the bioremediation. So here you can see that the contaminant is converted into non-toxic end products. So various methods are available now. Let's see. What needs to be cleaned up? It can be cleaned up by using this bioremediation, like soil, water, air, and sediments. That all can be cleaned up using these methods. Pollutants enter environment in different way, as already explained. Okay. Bioremediation. Okay. We can see this. How it is already explained. Okay. Come to the main aspect of bioremediation. So in the bioremediation, there are broadly it has classified into two types. One is in situ bioremediation and another one is ex situ bioremediation. You know what is in situ bioremediation is? Where remediation is done where the pollution has occurred, the land or soil or water where pollution has been occurred, there itself the process of bioremediation is carried out. So that is called in situ bioremediation. Ex situ means outside. So that means the the pollutant is taken away from the polluted place and treated somewhere else using various methods. That is called ex situ bioremediation. So in the in situ as well as ex situ bioremediation, again there are different methods are there. In the in situ bioremediation, you can see that different methods like bioventing, in situ biodegradation, biostimulation, biosparging, bioactive augmentation, natural attenuation. The ex situ bioremediation, it includes land farming, composting, biofuels, and bioreactors. So let us see one by one how we are process are carried out. So another method is also using plants. So it is also called phytoremediation. That definition is also a biological method. So in the phytoremediation also there are different methods I'm going to explain later. Now let's come to the main aspect in situ bioremediation. In situ means on site where the pollution has occurred. That is called in situ bioremediation. In that, bioventing is one of the methods, important methods of bioremediation, where one of the most common approach in soil, in the soil supply pollutants, where supply of air and nutrients to via wells takes advantage of indigenous microorganisms. So, for example, in the polluted the land with some compounds, but it is not. There are naturally there are so many microorganisms present in the soil, but they are not able to degrade that pollutants or utilize that pollutants. So what we have to do is we have to supply the air as well as nutrient to the these microorganisms which are already present. The indigenous microorganisms, they will activate it and they'll feed on the take the carbon source of their nutrients and degrade the pollutant. That is called bioventing. That means supply of air. Vent means air opening by to supply the air and nutrients. That is called bioventing. And in situ bioremediation is the supply of air and nutrients by circulating aqueous solutions through contaminated soils or groundwater also. And biosparging means injection of air below the water table. In the case of any water underground pollution, you can carry out increase the groundwater oxygen concentration and mixing in saturated zones. If there is no oxygen, the microorganisms will not be able to utilize that pollutants. That is called biosparging, injection of air to the below water table. And another method is bioaugmentation. Augmentation means addition from other source. In addition, in addition to indigenous or exogenous microorganisms which are already present, but they are not able to degrade that pollutants effectively. So what we have to do is we have to bring the microorganism from outside that land and add to the existing indigenous microorganism. That why it is called as bioaugmentation. Okay, limits to use of computation and necessity. And biostimulation, so which are already present in that, we have to stimulate the growth of microorganisms. And naturally attenuation also sometimes takes place. Okay, these are all the methods of in situ bioremediation where the pollution are removed removal of pollution is carried out in the place itself where it is pollution occurred using various methods. So in this picture, I want to show you how these processes are carried out. Yes. Bioventing is a process of stimulating the natural in situ biodegradation of contaminants in soil by providing air and oxygen to the existing soil microorganisms. What I have explained so far. This picture, vacuum pumps are used to supply the air. Air is blown to the underground also. Nutrients are also supplied to the that environments where the microorganisms can able to grow and to degrade the pollutants. Biosparging injection of underground table, water table, where air, oxygen, is nutrients are injected into the saturated zones to increase the biological activity of the indigenous microorganisms, can be used to reduce the concentration of petroleum constituents that are dissolved in the groundwater, absorbed to the soil below the water table and within the capillary frame. So naturally also all this process will takes place, but it will already explained also naturally also, but it will take a lot of time. Let us see what are the different steps which are involved in the bioremediation process. First, what we have to do when there is a pollution as reported from a particular place or land. So what we have to visit the site. Site investigation is also very important. Whether it can be everything cannot be treated by biological method. So they have their own drawbacks. All pollutants cannot be treated by microorganisms, plants, or biological activity. So what we have to do is we have to study the treatability, whether that pollutants can be treated, removed by the using microorganisms or not. That is called treatability study you have to do. And recovery of pre-products and removal of the contaminants also. When we treat with the microorganisms or plants or anything, either can be recovered of pre-products that are removed from the contamination source also very important. Design and implementation of the in situ bioremediation system is also we have to design, and monitoring on performance of evaluation. All these are the main steps which are involved in this application of this biological bioremediation process. Okay. Example, I'll give you ex situ bioremediation. I will explain the in situ. Now come to the ex situ bioremediation. What I explained is the performing the same process in place where the pollutants are removed and carried brought to the some other place where that all these facilities are available. So that is called ex situ bioremediation. For example, there are different methods of ex situ bioremediation. Land forming, that means contaminated soil is excavated from the polluted place and spread over land where it is a barren land or waste land, so that it can be used for this process. Soil is periodically tilted to improve the aeration so that the micro compounds which are present in that pollutants are evaporated. Remediation due to indigenous microorganisms as well as the chemical and physical process also can use, generally limited to the superficial of 10 to 35 centimeters of soil. And another method is composting. So composting, very common method of ex situ bioremediation, particularly municipal solid waste, domestic waste. In that it contains a lot of organic waste. That organic waste is separated and used for the composting. So this is for the composting. So that is called one of the important method of bioremediation. So it is a source of agriculture manure which is used for agriculture purpose. So, and then another method is the biopills. Combination of landfill and composting together is called the biopills. Controls physical loss of contaminants. So another important method in ex situ bioremediation is the use of bioreactors. Now, what is bioreactor? Bio means organism. Reactor is a control or environment provided in this process. That is, soil and water is pumped from the contaminated plumes and processed through the engineered containment system. Bioreactors are nothing but engineered containment system where we have designed that bioreactors in order to perform this process of bioremediation, where all these environmental conditions which are required for the removal of these pollutants or can be controlled. So that is why that is the main advantage of this in bioreactors. So it is a fabricated or engineered system where all the parameters, environmental parameters like pH, temperature, humidity, soil, moisture, everything can be controlled to achieve the maximum removal of the pollutants. That's the main advantage of this bioreactor. So yeah, degradation in a bioreactor is generally greater than the in situ in situ bioremediation. The in situ remediation, that process is very slow as well as depends on the environmental conditions. That environmental condition which we cannot control. Whereas in the bioreactors, we can control the environmental conditions which are required for the degradation of the pollutants. That is the main advantage of these bioreactors. It is very expensive as well as it is very effective when compared to the other in the other methods. So here you can see that ex situ bioremediation, there are different types of bioreactors are used. You can see that slurry phase bioremediation, where the uh, mm, liquid, it is in the form of slurry. Mixed, you can mix the contaminated soil with the water, oxygen, and fertilizers to stimulate the microbial degradation of the pollutants. So in this picture, you can see that. And another method I already explained is soil, the composting, okay, solid waste, biofuels. These are all the land farming, how we can perform this bioremediation process. So land forming, the diagrammatic it is shown. The thin layer of excavated content is spread over the land, and nutrients are added to the pollutants and in order to increase the activities of the microorganisms. Composting, I already explained. In composting itself, there are different types of composting, windrow composting, so many methods are there. Okay. And biofuels are also. So here biosystem offer the potential for the cost-effective treatment of contaminated soil. Okay. Still, I told you the bioreactors are different types of bioreactors. They are their own advantages. In a slurry bioreactor may be defined as a contaminated vessel, and operators used to create three phases: solid, liquid, and gases, mixing the condition to lessen the biological degradation of soil-bound and water-bound soluble contamination as water slurry of the contaminated soil, sediments, sludge, and biomass. Okay. There are so many advantages of this bioremediation, slurry, particularly slurry bioreactor, enhance the process control, faster rates of biodegradation, better physical contact between the pollutants and the microorganisms, distribution of nutrients, gases, and other materials for support of biological process, optimal soil, sediment, or sludge particle size distribution can be selected. Liquid phase organic pollutants may be enhanced by surfactant applications. So in the fixed bioreactor are there. There are different types. Another example is fixed film bioreactor. In the different types of bioreactor. Suspended growth bioreactors. I will not go in detail about all these things, but these are the example of different types of bioreactors. Okay, let us come to the how this bioremediation works. What are the feasibility and effectiveness of bioremediation? But I told you it is not effective as what in the conventional method, that we are the burning of waste, physical, chemical methods, but their disadvantages I already explained. But let us see what are the effective, how effective this bioremediation is, whether it is going to achieve the maximum possible remediation process. So here, it depends on three aspects. One is microorganisms, particularly used for this bioremediation process, and as well as the environmental factors, like what are the environmental factors? Include temperature, moisture, air, humidity, everything, which are environmental conditions. And contaminant types, I told you, all contaminants cannot be treated by biological methods or bioremediation process. Only the organic or the compounds which can be treated by this bioremediation process. So that is the main drawback of this bioremediation. So all pollutants cannot be degraded by these biological methods. So here in this diagram triangle, you can see that it depends on the environmental conditions like pH, redox potential, temperature, moisture, nutrients, and the compound structure also, I told you. And also type of all microorganisms are not effective. Only the selected strains or isolates are known to degrade this. That we have to identify and characterize those microorganisms. Then only can use these microorganisms. So these three things which are depends on very important. If there anything problem with these factors, it will not be completely degrade the pollutants. So I'll give you some of the examples of microorganisms which are enormously used for this bioremediation process. For example, aerobic bacteria include Pseudomonas, alkegens, Spingomonas, Rhodococcus, Mycobacterium, which are known and to degrade various compounds. They are shown to degrade pesticides, particularly pesticides and hydrocarbons, alkanes, and polyaromatic compounds are degraded by this Pseudomonas species. Alkegen. Pardon? Hello? Any doubt? Hello?
No, sir. Continue, sir. Class continue, sir.
Okay, okay.
Additional for other persons.
Yes, yes. So methanotrophs, the other types of microorganisms like called as methanotrophs, methane producing aerobic bacteria that utilizes methane for carbon and energy. So methane is produced, so that used in the environment that is used by this microorganism. Methane monooxygenase has a broad substrate range, active against wide range of compounds like chlorinated aliphatics and trichloroethane and 2,4-D, which is very commonly used for these various things that can be degraded by these methanotrophs. And also anaerobic bacteria are also used, not used frequently as aerobic, can often be applied to the bioremediation of polychlorinated biphenyls, PCBs, in river sediments, trichloroethane, TC is in chloroform. And these are all the examples of bacteria. There are some other microorganisms like fungi also used for this bioremediation process. They are able to degrade a diverse range of persistent or toxic environmental pollutants. I'll give you the examples. Let us see how these pollutants are removed or degraded by the microorganism. The mechanism which is taken place in the microorganisms. So all these pollutants or contaminants are served as primary substrate. That means source of carbon. They are enough available to the source carbon, source energy source, and they're called primary substrates. And secondary substrate, they also use it as a secondary substrate, provides energy not available in high enough concentration, and co-metabolic substrates also. So first is transformation of compounds by microbes playing on some of other primary substance. That is, these microorganisms use these pollutants as a source of carbon or energy. That is the main mechanism which is involved in this bioremediation by microorganisms. So here you can see that for toxic pollutants requirements. What are the important requirements for the microorganisms to degrade that pollutant? They required electron acceptor, oxygen, NO3, etc. And their environmental conditions like temperature, pH, electric conductivity, nutrients are also, so they are required. Here you can see that electron acceptor, electron exchange takes place during that process, and electron transfer, oxygen, NO3, okay, releases the byproducts like water as well as carbon dioxide also. And carbon energies, they also use some of the as energy source. Okay. If in the aerobic, there are two types already explained, aerobic as well as anaerobic. Let us see what are the difference between the aerobic and anaerobic process. If the oxygen is the terminal electron acceptor, the process is called aerobic biodegradation. All other biological degradation processes are classified as anaerobic biodegradation. In most cases, bacteria can only use one terminal electron acceptor. The facultative aerobic uses oxygen, but can switch over again to the nitrate in the absence of oxygen. Some example, aerobic oxidation, how it takes place, aerobic as well as anaerobic process, what are the mechanical chemical changes which takes place, denitrification of manganese reduction, iron reduction, sulfur reduction. So these are the chemical process or the mechanism which are involved in the is by remediation. So I told you already co-metabolism. What is co-metabolism? Some insecticides or allopathic aromatic or removed by the microorganisms. They use contaminate as a co-metabolic activity. So here are some of the example I show you. For example, organic chemical, okay? Organic compound, for example, benzene is one of the important chemical compound which is known to cause cancer. So that is removed by various anaerobic bacteria that is converted into carbon dioxide as well as water using a number of bacteria. So here also you can see the electrons are transformed to nitrate as electron acceptor. That is a mechanism. It is converted into carbon dioxide, nitrate, and water and biomass. So that compound is completely converted into some other byproducts which are not harmful to the human beings. I told you it's nobody, I'll not go into all those things. Some of the petroleum compounds are also hydrocarbons are used with oxygen. Here, petroleum compounds are categorized into two groups, aliphatic as well aromatic compounds. Here, the monooxygenase is enzyme which is involved in the produced by the microorganisms which converts them into byproduct or which are not harmful. Straight. These are some of the examples just to show you. Cyclic aromatic hydrocarbons. Here are also phenolic compounds or degraded by aromatic Achromobacter, alkanogens, Azotobacter, Flavobacter, some of the bacterial microorganisms which are commonly used, and some of the fungi, Aspergillus, Penicillium, Arthrobacter, Bacillus are also used. Surfactants also used. Pesticides are also degraded by E. coli, Pseudomonas butida, Pseudomonas aeruginosa. Genetically modified, also genetic regulation of this also used. What is the plasmids which are involved in these examples? Okay. I have told about that how these microorganisms are used to degrade these pollutants. Now let us see to assay the system of whether it is degraded or not. We have to confirm it. How to confirm that compound is degraded by these microorganisms or not? How there are so many methods to degrade and determine or assay to study the measurement of oxygen consumption by manometric and electrolytic system, measurement of carbon dioxide evolution by infrared chemical methods. So some of the methods in order to monitor. Use of radio labeled substrate, measurement of the disappearance of the chemicals by gas chromatography, determination of the reduction of dogs, chemical biological activity, and conditions. So some of the methods to confirm that whether that compound is degraded or not. So in addition to that, genetically modified microorganisms, what I have explained so far are the naturally occurring microorganisms. You know what is genetically modified microorganisms? The genes of the microorganisms are modified in order to enhance this process. They are genetically modified. So one of the important example is the genetically modified bacteria is the it is created in 1970s itself, long back, using the Pseudomonas butida is genetically modified microorganisms. That is where the contaminated plasmids that encoded genes for breaking down the particularly oil pollution to degrade the oil pollution, control the oil pollution. This bacteria is genetically modified. So that genes encoded for the breaking down of pollutants are incorporated to this bacteria. So that is widely used. Applying example, E. coli also used genetically modified strains of E. coli also used to clean up the heavy metals, particularly copper, lead, cadmium, chromium, and mercury also used. Here also this is the just trying to show the how these genetically modified microorganisms are produced. some of the environmental factors which are depends on the okay. I told about this. So far, I explained about the use of microorganisms in the bioremediation process, that is to removal of pollutants from the environment. Now let us see the use of plants to remove the pollutants or degrade the pollutants. That is called as phyto. The another terminology used instead of bioremediation, use the term itself phytoremediation. Phyto means plant. Remediation is use of plants. Use of plants to this process is called phytoremediation. In phytoremediation itself, there are different methods out there. What are the different methods of phytoremediations? Example, phyto extraction or phyto accumulation. Here, phyto extraction, the term itself explains. Phyto means plant, extraction. Extraction of pollutants from the soil using plants. That is called phyto extraction or phyto accumulation. Or the pollutants in the soil are going to accumulate in the plant system, in the root, in the stem, in the leaf, in the flower, fruits, everything. They are going that absorbed and accumulated in the plant. That's why it is called as phyto accumulation. The plants used to accumulate the carbon in the roots as well of the above ground biomass can be relatively low cost option for large areas. Results in biomass that must be properly disposed or reused. Another method is the phyto transformation or phyto degradation. When the pollutant present in the soil, which is absorbed by the plant through root system and enter into the plant, and it will not remain in the same form. It is transformed from one form to another form during its metabolic activity of the plant itself. That is why it is called as phytotransformation. So in the previous method, that is in phyto extraction, the pollutants remains the same in the plant system and accumulate in the root, stem, or soil, flower, or whatever, but remain in the same form. But whereas in the phytotransformation, the pollutants which are absorbed through the root system is converted into some other compound. Okay, that is called transformation or phytodegradation. Example: metal chromium can be reduced from hexavalent to the less mobile trivalent compound. You know the importance of metal, that is chromium. Chromium is widely used chemical, which is metal for electroplating. So industries, they use a lot of chromium, particularly hexavalent chromium is highly toxic or carcinogenic compound. That hexavalent chromium is converted into trivalent chromium, which is not toxic by these plants. The plants absorb the hexavalent chromium and convert them into trivalent chromium. So that is why it's called as phytotransformation. The another method is phytostabilization. So that means mobility and migration of contaminants are reduced through the sorption into the sorption onto or into the plants. So that is stabilize the pollutants in the environment. And rhizodegradation. Rhizo means roots degradation. Degradation of pollutants in the root system of the plants. That is breakdown of contaminants through the activity of the rhizosphere. The rhizosphere means, rhizo means root, sphere means the area which surrounds the root is called rhizosphere. That there are a lot of microorganisms are there and a lot of compounds produced by the root that are going to break down the contaminants which are present around the roots of the soil. That's why it is called as rhizodegradation. And rhizofiltration. Rhizofiltration means water remediation technique. It is also called as water remediation technique, used to reduce contamination in natural wetlands and estuaries and areas that plants act as filters to control this pollutant. That's why they are called rhizofiltration. So in the picture, I will show you all this what I explained so far. The methods in this diagrammatically given in this picture, in this slide. So in the phytovolatilization, the first part, you can see that here, you can see that that means when the pollutant is absorbed by the plant root system, it enters into the plant system and again volatilize, enter into the atmosphere, which is okay. And phyto extraction, you can see the accumulation of these pollutants. Phyto degradation also, some of the compounds will be degraded into some other compounds. Phyto degradation, all these are represented in this picture. Contaminant here, this sigma symbol shows this is a contaminant, and this is a stabilized contaminant. This diagram is a stabilized contaminant, whereas square shows the gaseous state of contaminants, and this diagram shows the degraded contaminant. You can see that here the degraded contaminants also. So these are diagrammatic representation of the process which I already explained. So same time, same thing which I have, phytostabilization, phytostimulation, phyto extraction, phytovolatilization, now these are explained. Non-biological remediation, okay. So here, these are the compounds which are known to degrade by these plants: mercury, selenium, Pc, heavy metals, radionuclide, etc. So what are the advantages of this method? Can compare to the other methods? They are cost effective when compared to other more conventional methods. Nature method, it's a natural method. We are not going to add any unnatural or chemical things which to the environment. So it is a nature method, more aesthetically pleasing, minimal land disturbance, reduce potential for transportation of contaminants by wind, reduce soil erosion. So when you grow the plants for this purpose, it also helps to reduce the soil erosion. Hyperaccumulators of contaminants mean a much smaller volume of toxic waste. Multiple contaminants can be removed with the same plant. Same plants can be used for removal of various types of pollutants, that is multiple contaminants. There are some disadvantages also. Not any methods, they have advantages as well as disadvantages. Okay, what are the disadvantages of this? It is a very slow process. Any natural process are very slow process when compared to the chemical or physical methods. So in the chemical physical methods, that is burning of waste, this incineration, within a few hours, we can remove, reduce, and destroy the pollutants using high temperature incinerator. Whereas this method is very slow rate and difficult to achieve the acceptable levels of decontamination. Potential phase of transfer of contamination. Possibility of contaminant plants enter into it. There is also some disadvantage, like there is possibility of this pollutant, if you use the plant, there is a possibility of contaminated plants enter into the food chain. And possibility of spread to the contaminants through the falling of leaves and all this. So even though plant, they contain the pollutants in that system, that also possible of spreading to through the falling of leaves or other materials. Decrease in oxygen during winter months. Trees are dormant. Trees and plants require care. Contaminant might kill the tree if it is in high concentration. If the pollutant is present in the soil, if it is in high concentration, this phytoremediation cannot be used because the plant cannot tolerate this high concentration. That plant might, the contaminant may kill the tree. Degradation products could be worse than the sometimes reverse also. In the soil, the pollutant which is present is not much toxic. When entered into the plant system, it can be converted into more toxic than the original compound. There is also possibilities are there. So we have to see all those things. Much testing is needed before procedure can. So a lot of testing of required before using of these plants for phytoremediation. Okay, so I'll give you some of the success stories of these methods where it's very effectively used in the world in the present examples. So in the 20th, the most common element in the earth crust is the human body, that is arsenic. Okay, arsenic is one of the important pollutants. So it's a major worldwide contaminant that can rise through the industrial activity like pesticide mining, combustion, etc., from soil and groundwater, associated with the acute poisoning of linked to what liver, lung, kidney, bladder, cancer, etc. Okay, so this how they are removed this arsenic from the environment. The success story. So in India and Bangladesh, okay, 400 millions of people risk of arsenic poisoning, and 40 billion drink water contained with this arsenic. So in this way, arsenic is removed effectively by using a plant, using focus on the phytoremediation. Okay, this plant for phytoremediation is used for this removal of arsenic. Okay, Arabidopsis, plant which is used is the Arabidopsis, the plant used in order to accumulation by accumulation of arsenic. See, a bacterial arsenic reduction catalyzes the reduction of arsenate into arsenide. Okay, some of the methods, chemical changes which are taken place in the plant system when the arsenic is absorbed by the plant is converted into less toxic compound. So here you can see arsenate reductase. The enzyme which is produced by the plant is majorly responsible for this process. Here you can see that. The prokaryote genetically modified also. Genetically modified Arabidopsis plant also used. So the bacterial, some of the assays to confirm that arsenic is converted, is degraded or not. There are so many methods in order to confirm that. So in addition to that, there are so many other plants are also used. For example, Teres vitata, one of the popular known plant, which is also known as Chinese ladder fern. The common name is Chinese ladder fern. Teres vitata is a natural arsenic hyperaccumulator. This plant is known for the accumulation of arsenic naturally. Can tolerate soil concentration of 1,500 micrograms of arsenic per gram. So even such high level of concentrated arsenic present in that soil can be absorbed by this plant. Okay, that is called as Teres vitata. One of the important, the striking difference between a very common plant which is used for the phytoremediation, particularly arsenic accumulation. So these are some of the examples. There are different plants are used for different types of pollutants and their concentration also. Okay, just you can see that. So another example is one of the important plant species is water hyacinth. Eichhornia crassipus is very commonly used to remove the phosphorus pesticide. Now, phosphorus is one of the important pollutant fertilizer used. It is present if it enters into the water body, which encourages the growth of algae and other water microorganisms. So this water hyacinth is used to remove this phosphorus from the water bodies, so in order to reduce the nutrient concentration in the water body. Okay, the accumulation of methane leaves hyacinth plants decreases by 55 to 91%. Some other things are also used for this purpose, like chlorinated hydrocarbons and other the mass balance between field of carbon tetrachloride phytoremediation using popular phytoremediation. Okay, these are the plants not already used. So another plant is used for this degradation of pollutants is the pig slurry cleanup. It's called using the plants is called duckweed. That is called lemma. Okay, you can see that. Here also you can see that another plant where the rhizofiltration takes place. Okay, rhizofiltration, the plant species which have very high root density or system, they are used for this purpose. Some of the explosives are also degraded by the microorganisms as well as the plants. For example, TNT, RDX, these are also degraded by some of the plant species. In addition to that, there are so many examples of, particularly in saline soils. Salicornia, pickleweed, accumulates the salt in vacuoles, a form of table salt that can be extracted from the plant. Where the soil contains a lot of salinity is there. So these plants, if you grow, it will remove the soil from the soil and accumulates in the plant system. That's why they are called as relation of saline soil, particularly saline soil. It accumulates the salt in the roots and the stem. Then later it can be extracted. Water, so there are some other of water also for water, groundwater cleanup also. Some of the methods are used. I already explained all those things. Turning into waste to energy, different strategies are there. Okay. So these are the examples. As I will come to the advantages and disadvantages of this bioremediation as a whole. Bioremediation is a natural process and is therefore perceived by the public. And bioremediation is useful for the complete reduction of wide varieties of contaminants. Instead of transforming contaminants from one environmental medium to another, for example, from land to water or some destruction of pollutant is possible by this method. There are so many disadvantages also. Bioremediation can be carried out on site, often without causing a major disruption of normal activities. These are some of the advantages I'm explaining again. It also can prove less expensive than the other technologies. So use of microorganism plants are not much expensive, can be highly specific. If increased mineralization occurs, it complete degradation and cleanup. The process is very simple process. There are some disadvantages of this bioremediation. Is limited to those compounds that are biodegradable. Not all compounds are not biodegradable. Only some compounds which are biodegradable can be treated. Okay. There are some concern that products of the biodegradation may be more persistent or toxic than the original pollutant. That is also one of the important concerns. Okay, these are some of the disadvantages of bioremediation. And also, biological processes are often highly specific. Microbial population, suitable environmental condition, growth conditions, and appropriate levels of nutrients and contaminants. It is difficult to explorate from bench to pilot scale studies to fulfill the field of. That means the laboratory condition, the field condition, it can sometimes there is a lot of difference. Bioremediation often takes longer than the treatment point. Not instantaneous, often need to develop a system, always need to test and optimize the condition, may have inhibitors present. Compounds may not be in a biodegradable form, polymers, plastics cannot be treated. Compounds may be recalcitrant, also cannot be treated. These are some of the disadvantages. Okay, I'll give you one more example where jet fuel and South Carolina and Exxon vessel oil spills in Kuwait. They have successfully removed the oil from the shore, the oil spill, oil contamination, oil pollution. I'll show you the picture, you can see that. In particularly, yes. Okay. Yeah, but in 5 minutes, yeah. Another example is South Central Alaska. They used Central Alaska, beautiful and unique place. Some around has many islands in that place. Okay, entire reason is national wildlife refugees. So here, what they use, the oil was spreading and contaminated more beaches every day. So cleanup methods had to be decided upon by prevent the pollution. They use this biological method. This is known as Alaska Bioremediation Project, which is started in 1989 in King Island. The project was designed to determine the feasibility of biodegradation enhanced by fertilizers, nutrient application in 1989. Selected as a first test to site because it had a long length of shore with several beaches, materials. They got very good result by this biological methods, bioremediation, approximately about 10 to 14 days visual reduction in the amount of oil covering the rocks at present. Also visual reduction in the oil covered on the gravel beach. Further test proved that this reduction is due to bioremediation and proved that this is not due to the chemical cleanup. Okay. So these are one of the important success story used in the Alaska. Okay. So here you can see that some of the pictures of this process. Thank you. If you have any doubts on clarification, it's open for participants, dear participants.
Sir,
Yes.
you covered that environmental issues,
Yes.
but what about the noise pollution is coming now? What do you think, sir? That all nowadays we are